Right. Hello, everyone. We're about to start. So if you're here, please turn on your cameras. See. All right. So share screen. Good. So yeah, I hope all of you get the chance to view the video I posted to Panopto. So there is it's supposed to be an in-class activity, but you'll do it by yourself online. And in that, I made a video in which I went through how to conduct pivot tables in Excel, and then how to do a cross-tab comparison, or what they would call contingency tables, in which you have a cross-tab comparison, like two variables, and then you make the expected value table out of it, right? And that's a way to measure the difference between proportionality of one variable as it's supposed to be if there were no relationship in comparison to the actual results. And so I made the table out of the smoking status table I showed last time, right? And based on these numbers, you should be able to answer if male and females are proportionate to their numbers of being smokers, past smokers, non-smokers, or not. So is it proportionate or disproportionate? And if there's disproportionate representation, which one of the two is overrepresented and underrepresented in terms of being smokers, past smokers, non-smokers? So that, yeah, please view that and let me know if you have questions. And so we're going to continue today where we've left last time. So I'm going to talk about levels of measurement, how it relates to the level of variables. What does that? So the question you might ask is, why should I care that variables have three different levels of my measurement, nominal, ordinal, continuous, and continuous has like two others? Like, what's the point? And the point is, because based on that, they would be different statistical tests depending on what the independent variable is and what the dependent variable is, or what the predictor or outcome variables are. And so depending on how you measure the first variable and the second variable, how you draw the relationship between the two, depending on what each variable is made of. So let me give you an example so this point will become clear. So suppose you're investigating the relationship between narcissism and Instagram posting, okay? And the hypothesis is, as the level of narcissism increases, frequency to post to Instagram increases. So the hypothesis is simply saying people who score high in narcissism would tend to post more stuff or more pictures of themselves on Instagram. So here's the trick. Here's the question. So suppose in one quiz or one test, you ask participants to rate themselves as either narcissist or non-narcissist. So do you consider yourself a narcissist? Yes or no? Or like, how would you rate yourself? Narcissist or non-narcissist, right? So this is a binary variable. In another quiz, you actually you measure narcissism level as a continuous scale. So you created a scale, let's see, with 3 questions, and then you ask participants to indicate to which level do they agree, from 1 to 7, right? So do you like looking at yourself in the mirror? You think you're the best among your peers, and you think you're an exceptional person. So let's call that narcissism scale, 3 questions, and each one had a range of 1 to 7, and then we get the average score, right? The question is, which one of the 2 quizzes would allow us to test the hypothesis more precisely? And depending on the answer, why so? So what do you think? Which one would allow us to test the hypothesis more precisely? First quiz or the second quiz?
The second quiz, because it gives a range between 1 and 7 versus just yes or no.
Right, right. And what's the pitfall of just posing one question as yes or no? What's the downside of that?
Well, people only have two options, or people will lie and say no or yes.
Yeah, right. So the idea is like there are people in the middle. And so I could ask you, to what extent, even if I ask you, to what extent do you think you are a narcissist or you have a narcissistic personality, right? Many, I would think the vast majority, so assuming the scale runs from 1 to 7, I think the vast majority of people would pick some point in between. Some people would say 3, some would say 5, some would say 4, etc. And so that's the case. So you would allow for a more accurate representation of where people think themselves or think about their personality, right? And so you'll get more precise measurement. That's the point. And we call that validity, if you remember. So we were talking about the measurement and the ability of the quiz or your question to detect variance or small differences between participants. We call that variance, the ability to catch variance among participants. That's more valid. That's a more valid way of assessing it. If you just ask a binary, so as Grant said, like you would force people to either lie or just to sort themselves into one of the two extremes, all right? So that has to do with the validity. Another point, do you notice the language in the hypothesis? Can someone read the hypothesis, please?
As narcissism increases, frequency of posting to Instagram increases.
What do the first 3 words say? Could you repeat it?
As narcissism increases.
And what does that entail? What does that say? So it's what?
Entails like just like a, is it a kind of like a subjective thing?
Yeah. My point is, as narcissism increases, you see frequency of posting also increase. So it's more like what? You should see what? What should we see in the data? If this hypothesis is true, what should we see? The word start with the C. We should see something between the two variables. Yeah, thank you, Alyssa. Oh, and you get positive, right? We should see a positive correlation because as narcissism increases, we're not only saying that narcissists will post more to Instagram, we're saying it's gradual. So if you're like at one level of narcissism, let's say you post none, at 2 you post a little more, at 3 even a little more, etc., etc. So we're saying as narcissism increases, you should see a line going up for narcissism, and then frequency of posting to Instagram should go up as well. So that's correlation. And here, and that's because they're like we're having 2 continuous variables. So obviously posting to Instagram is continuous. So each post, that's 1 second post, third post, like 1, 2, 3, 4. That's like a numerical, actual, continuous variable. And then narcissism scale continuous. So you could look at your correlation. If you're having just 2 groups, so you just cluster narcissist or highly narcissist or low narcissism in one cluster and high narcissism in another cluster, what you can only do is mean comparison. All right. So you compare the mean of the group of narcissists to the group of non-narcissists in terms of the mean score for posting to Instagram, right? So the mean score for group A, the mean score for group B, and compare them. And that's because one variable is categorical and the other is continuous. All right. So that's the thing. If the two variables are categorical, we've done something we would call chi-square test, or which is a test based on the cross tabulation. So when you have two categorical variables, so that's the example I gave about gender and smoking status. Well, let's say, for example, being a COMM measure and gender, right? So COMM measure versus non-COMM measure. So that's a categorical variable, right? It's just you either belong or don't belong. It's even numerical. And then you have gender. So you have male, female, and other, right? So, and we could see the proportionality. So proportionality, we do it when you have two categorical variables, right? There's no way for us to do correlation because there's no continuous scale, right? There's no like gradual increases in measurement. Right? We do that only, we're allowed to do that if we have a numerical or a continuous scale. If you're comparing to proportionality, so let's say, for example, home ownership and state, right? So if you, or like region, for instance. So do people in the suburbs of San Diego tend to be more homeowners than the people who live within like the city itself, right? City of San Diego versus the suburb. You can do different counties. So home ownership across counties in Southern California. So homeowners, non-homeowners, and then you have like different counties. And you want to see the proportion of homeowners in each county. That's categorical to categorical, right? If you're doing, for instance, income, not income level, but actual income, like in dollars, and in comparison to like county that you live in. So you would have a continuous and categorical, right? So we could see the mean income across different counties, and that's the mean comparison test, right? And so, yeah, that's how it is. So if it's like categorical to continuous, continuous to categorical, continuous to continuous, categorical to categorical, right? So that's the different tests we have. So the ones we're going to, so chi-square we covered today, and then the mean comparisons we have two. If we have two groups, it's called the t-test. If you have more than two groups, it's called the ANOVA. But honestly, it's the same thing. It's just you comparing the mean. But we don't look at just at the raw number of like mean or like average points. We look at the mean and distribution for reasons I've explained last time. And if it's too continuous, we do correlation. It's something else called linear regression. We're not going to cover in this class. You need to take COMM-365 to continue with more of this. And the whole idea is to show if there is a relationship or there is likely a relationship. So the whole point of doing those statistics, again, is like you have a hypothesis in mind and you want to prove that null hypothesis is false. That is to say that there is no relationship. You want to show actually there is some sort of a relationship. What it is, that's another matter. But what we do in hypothesis testing, and this might sound weird, we try to falsify the null hypothesis, but that doesn't necessarily mean that the stated hypothesis is true. So it's not always the case. So I'll give you an example. So if I say there is no relationship between income and the neighborhood you live in, that would be false. Because we could show that some neighborhoods or some counties or some zip codes have a higher income level than other neighborhoods. But that doesn't mean I know from that which one caused the other, right? So it's in other words, because you lived in that neighborhood, you became rich, or because you became rich, you moved to the neighborhood. You know what I mean? So the relationship direction is not necessarily proven. If I showed an association, I still don't know like how it happened, right? Like what caused this correlation. But we can say for certain that if you say there's no relationship, it's just false. Of course, there is a relationship. We cannot deny that there is a significant association between the place you live in and your level of income. So that's just disproving the null hypothesis, but that doesn't mean you have a hypothesis that could explain it. You have to run other tests to see like what caused it, right? So that's a technical difference that will become very important as we progress. So chi-square, actually, I already covered online, I'm going to cover, but chi-square, which you're going to do, some of it is basically you would do the crosstab to see, for example, I already gave, if the distribution of male and females in each category is equal to their distribution in the total. So if we have like a 52 to 48 split, we should do 52 to 48 split here, in the second one, like here, and here. We should do the same distribution across. And so you're being asked to do this exercise in which you would compare the actual frequencies or the observed. So you do this is O for observed, and the expected frequency. So expected frequency is you do the split in the sample, 48 to 52, or whatever percentage you get in a different sample. And then you see if the observed frequencies or the observed or actual are the same thing, are similar to the expected. And then we test of the difference between the two, the observed and the expected, is significant or not. If the difference is significant, we reject the null hypothesis. So yeah, we say, obviously, yeah, saying there's no relationship is false, i.e. the difference is not due to random variation. There is something going on, right? So we reject the null hypothesis. The way we know, and here's the key point, how do we know if it is significant or not? So if the difference between expected and observed is just 1 or 2, is that a significant difference? What we would do is then we calculate the chi-square and the p-value. Chi-square, by the way, is just once you're done calculating the difference between the observed and expected for all the units for the full table, you then divide it by, you then actually then raise it to the power of 2. And that's for, if you remember, that's just to get rid of the minuses. So when you raise something to the power of 2, then yeah, you're not interested if it's +2 or -2 or +3 or -3. You just want to see how different it is from the observed, right? Even if it's plus or minus, you want to cancel that out, right? Hence, you raise it to the power of 2. And then you divide it by the expected. And if it's the same value, you should get 1, right? If the observed is similar to its expected, you get what? 0, right? And 0 to the power of 2 is still 0. And anything, when you divide 0 into like, so 0 divided by any number is 1. You remember your middle school or high school math. And so if it's 1, then it's an actual match. It's the same. And as it goes and it's become larger, obviously you are seeing like a larger difference, or like a smaller, sorry, it gets smaller, so fractions mean there's some difference. So the chi-square is always between 0 and 1, right? And so that by itself won't tell us if it's significant or not. But then we would look at something called the p-value, all right? And the p-value would tell us if this difference is statistically significant. That's the word you would hear a lot. So statistically different or statistically significant, that's something we would learn. We're not covering p-value today. That's something we'll look into when we look into distribution and other tests. So we will save this for later, right? Okay, so that's telling you about the tutorial. So I already posted the video. Here, again, I'm showing you the different tests. So we're going to cover t-test and ANOVA. So t-test is a binary IV with 2 categories, and the DV is continuous. So the effect of gender and how well you did in the exam. Or let's say the effect of being from California versus being from outside California on satisfaction with life in campus, something like that, right? So satisfaction with life or level of income is continuous, and then we have 2 groups. So t-test, to remind you, is a mean comparison test. ANOVA is the same as t-test. It's called also F-test, but you have more than one IV. So you have, like, if you're from, let's say, comparing people from San Diego County to people from Southern California, like all of the 14 counties, and then to people from the state as a whole, then to people from outside the state. And so these are like 4 or 5 groups. And so, yeah, you do an ANOVA, and then satisfaction with school will be continuous, right? We won't do MANOVA, which when you have multiple IVs, so you're not testing relationship between 2 variables, you're testing relationship between multiple variables to a dependent variable. We're not going to do that in this class, but then we're going to look into correlation, which is obviously just 2 lines of 2 continuous variables. And so that's, let me see if we have time. So that's so that's just an introduction. Now I like to spend this time, so I would like you to just introduce Jamovi, just for like 10 or 15 minutes. I would like to introduce Jamovi, the software. So if you go to Blackboard, the link is already posted. So I want to know if people can install it and it's running, and then I'll show, if we have time, just a review of the app. So I'm just going to stop sharing the PowerPoint. So if you go to Blackboard, you should see a link. And I can even send you to you here in the chat. And let me know if you have any troubles with it, or if you have installed it already. So to show you how it looks like, I'm just going to share the screen of the app itself on my computer. So here. Yeah, sure. I just want to get the chance of people here. So usually the recorded videos don't get like a lot of traction, and so just because I want to like hear your feedback and clarify some things about how to use the app. So I'll give you like another minute, and then yeah, this is just a tutorial, so you won't be missing a lot if you didn't install it already. Okay, does anyone have it installed? Or are you still working on it?
It's still downloading.
Okay. Yeah. So just to use time, so actually the file I'm opening is the one with sidecar donuts. So it's already uploaded to Blackboard. And there's something you need to do first in order to be able to open it to Jamovi. There are multiple ways to do it. So let me share my Excel spreadsheet. So this is the file I uploaded to Blackboard, which you worked on before. This should look familiar. So this is the one where you did the category codes, all right? And to make this work on Jamovi, what you're going to do is just like obviously open Excel, go to File, and then, well, let me save copy or save as, because I haven't saved it. And here, instead of Excel workbook, XLS, you choose CSV, all right? And make sure it's like you don't override your old file, you save it as a new file or a new copy, and then save. It will give you a warning sign, just click on OK, and then that's it, okay? Now this file that is CSV, you can then open it with Jamovi, right? And I'm going to show you how to do that. And so I'll share the screen again. So here it's the same file. You can see here the tweets, category date, day of the week, weekday, same table, right? the way to do it is just to click on here, open or import, and then you would be able to choose it, right? So mine is right here. You could see, yeah, like CSV is this one. And because I already imported, I'm not going to do it again. But this is how you import a CSV file into the Jamovi. By the way, you can import an XLSX file as well, but only if it has one sheet. So Jamovi could only import one sheet at a time. It cannot import multiple sheets within one file. So you can separate your sheets into different files, or just do as I did, convert to CSV, and then it will import the first sheet automatically. And so I'll spend like, yeah, just 10 minutes just showing you around, and I'll do also another recorded video and asking you about another exercise. So there's a lot of short exercises coming this week and next. So this is, as you could see, very similar, or not very similar, let's say similar without a very, to Excel. But it's similar, like, so you have columns and you have rows and you have the values, and it's the same here. Here, if you click on the name of the variable right here, category code, click on setup, you see what it says in here? So it says nominal. That's mean categories that, so these numbers don't carry an actual numerical value. These are the category codes. Some of you, I used one of the codes that one group of you have done. I don't remember which group, but this is done by students. So you see what it says here? Nominal, ordinal, and continuous. And I like the drawing. So nominal just showing you as 3 separate groups. Ordinal is like, okay, you have 3 ranks, so you go up a little bit, but you don't have like fractions. And then here, continuous, you have like a roller, and it's so like it's an actual continuous scale. You start like you don't only have ranks, you actually have fractions, actual numbers, in which things are distributed continuously, or numbers are distributed continuously, right? And so it's telling you what's the type of the variable, right? So here, let me just, yeah. So here is showing you category code. This is ID, meaning it's not really a variable, it's just an identification, so it's just the date. Day of the week also, so yeah, it's categorical, so Monday, so it's starting, yeah, Monday is 1, Tuesday is 2, right? This variable is called weekday or weekend, so weekday is coded as 1, weekend as 2. This is time, as in what time, so 23 is 11 o'clock. But yeah, 15 is 3 p.m., 7 is 7 a.m., right? Is it, and you see after work hours or not? So if it's after work hours, after 5 p.m., it's 1. And then it's 0 if it's not after work hours. So you could see, yeah, it's also categorical or nominal. And then you have favorites, that's the number of likes. So we can actually rename it. Let's say likes, or just to make it easier, and retweets, etc., etc. So let me show you like a few things. So here, to run the actual statistical analysis, you go to analysis, and to find the descriptive statistics, you click on the first thing, exploration, right? And then you click on descriptives. And then you see here, these are the things we were talking about. They're called the central tendency. So you see here, mean, median, mode, right? And then we have sample size, like a number, and this if it's valid or not, hence it's showing you missing. Standard deviation, variance, minimum, maximum value. You see all of that. Range is maximum value minus minimum value. So let's just keep standard deviation, mean, and median, right? That's what we need. And then if you want to know what is like the average like number of likes. Okay, we put it right here. Right, so we read this table right here. We have 107 tweets. None are missing. The mean is 5.8 or 5.9 to round it up. So the average tweet gets 6 likes. That's the average or the mean. The tweet in the middle got around 5. So the sample is a little bit tilted to the positive side. So there were like a few tweets that basically lifted the average above the median. Standard deviation is 3.5. So on average, a score is 3.5 away from 5.8. That's a standard deviation, right? So we have scores like that has 8 or 9 likes, and scores that got like less, which is like 2 likes or 1 like. But on average, each score is 3.5 likes away from 5.9 likes. Okay, the minimum tweet got 0 likes, and the maximum got 19 likes. Okay, and then if you even scroll down in the plots, you could click on histogram, which would show you the distribution. All right, so click here, histogram. So these are number of likes. So you could see here, right? There are more, like, so this is 5, and you see the average is somewhere right here. But there are more values actually below the average. That's why the median was smaller than the average, right? Or the median was smaller than the mean. The mean is the average. And there's one tweet here. If you see, this is what we would call an outlier or an extreme value that sort of pulled up the average a little bit, right? Like we have here, like a few, like 1 here and 20. Yeah, like pull the average up a little bit, right? And so those are descriptive statistics. One good thing about your movie, so it's super easy to use. You can also you can, if you have different variables, you can split by categorical variable to see the difference. So if you click on, let's say here, you want to see the likes per day or like weekday, okay, or day of the week. So we would split the likes, the average likes, by day of the week, okay? And so here it's showing us, yeah, so each day of the week, right? And then the the mean number of likes, right? And here's the frequency. So 20 posts were on Monday, 17 tweets were posted on Tuesday, 17 on Wednesday, etc. The mean for likes is right here. So it's 5 for Mondays, 6.8 or 6.9 for Tuesdays, 6.24 for Wednesdays, etc. And you see it's dividing all the things, right? You see the distribution per day, etc., etc. You can do like a frequency table as well, and we'll give it to you right here. It's, yeah, this is the one we have. So now that's just the descriptive statistics. Something that you could also do is if you click on frequency, that's the cross tab. All right. And we will show you, I want to show you the chi-square. And so here you have something called like goodness of fit. That's a chi-square. So here chi is like x squared, and you click on it, right? And then here you would just see, you could look the variable you're testing, so the independent variable, and count is the, so let's see, for instance, if we have an association between, let's say, 2 things, right? So let's do the same, right? So let's do weekday or weekend to make it simpler. So we have two things. So all weekday tweets in one category, all weekday tweets in another category. So weekend versus weekday. And then here you would see likes, right? And this is the p-value. So it's showing actually that the difference between the two is statistically significant. I could also show you, if you do this one contingency table, this is an easier way to do it, which would show you the difference between two things, two categorical variables. So let's say, for instance, if we want to see the association between post on the weekday and post on after work hours. So does this donut place post more in the day during weekdays and more during the night during weekends, if there is an association between those two things? So here, what you would do again, so you see here categorical variables only. So let's do weekday or weekend. And then after work hours would be columns, right? And then it would show you here the it would show you the difference, right? It would show you the distribution. So 1 is weekday, 2 is weekend, 0 is before or during work hours, and 1 is after work hours. So you could see here, for instance, that there is a mismatch between work hours before work hours and weekday. So right here, more than during work hours and the weekend, right? So this is across tab as well. You could see how two variables are proportionate to one another. And so, this is just a quick tutorial. I'm going to do more even recorded videos, so you could go back to them. And so the next activity, activity 5, would be on Jamovi. So now I'll stop right here. Do you have questions? Yeah, go ahead, you listen.
I have a question towards the grade book. I was checking my grades last night, and it says the last exam was out of 25 points, but on both the course content on Blackboard and while taking the exam, it says it was out of 20 points.
Yeah, that happened to me too.
Yeah, apologies for that. That was just